You're watching a screen. Well, if it goes down, every particle, every thought, every moment rendered. Not philosophy. A physics hypothesis with testable predictions. The quantum leap. A physicist at MIT is running the experiment right now. It started with a paper. Oxford, 2003. Nick Bostrom, The Quantum Leap. We build the world science creates. Everything you'll experience today is real, not yet happened. Oxford philosopher Bostrom published a paper in 2003, A Paradox. One of three things must be true about our universe. Either civilizations always destroy themselves before building simulators, or advanced civilizations have no interest in running ancestor simulations, or we are almost certainly living inside a simulation. The logic is airtight, the implications are devastating. Here's why most physicists take this seriously. As physics, our universe has laws, precise, mathematical, absurdly fine-tuned. The gravitational constant, the speed of light, the electron mass. Change any constant by a fraction, stars never form. Not a coincidence. A design signature for designer exists. What strikes us, physics keeps finding the universe is mathematical. Max Tegmark at MIT argues, the universe is mathematics. Then there is no difference between physical and computed. That boundary, real versus computed, may not exist. Philosophy without evidence is speculation. Physics demands a test. In 2012, Silas Beane asked a question about simulation signatures. What does a simulation look like from the inside? We already build physics simulations on lattices, discrete grids. Every lattice point has a maximum energy, a hard limit. Beane asked, does our universe have a hard energy limit? Yes. The GZK cutoff. Nothing exceeds that energy threshold. That limit matches exactly what a lattice computation would produce. Beane's preprint was not peer-reviewed. We say this clearly. The cutoff has other explanations. Most physicists favor them. The simulation interpretation has not been ruled out, that matters. Enter the holographic principle, string theory's most uncomfortable prediction. In 2013, Hyakutake at Ibaraki University published a landmark result. He showed 3D gravity matches a 2D description without it. The universe may be a projection, a flatter hologram. Nature published it. This is established physics, not speculation. When we encountered this result, we checked the methodology twice. A 2D description predicting a 3D universe, not metaphor. It is a mathematical fact that demands an explanation. It is 2038. You are reviewing Planck scale detector data. The results have been replicated at 6 independent facilities worldwide. The energy cutoff is not cosmic. The universe has pixels. Papers submitted to physical review letters. Review takes 8 months. That is the future. Here is what stands between us. No Planck scale detector yet. Building one requires civilization scale energy. The LHC probe scales 1 trillion times larger than Planck. We would need a galaxy scale accelerator to reach it directly, but indirect signatures may be accessible. That is Beane's work. The observable prediction, lattice simulations create anisotropy directional patterns. In a lattice simulation, cosmic rays should arrive slightly unevenly. The Pierre Auger Observatory in Argentina is measuring this now. They have 1/600 detectors spread across 30 square kilometers. In 2012, Beane found something strange in cosmic ray data. Cosmic rays hitting Earth have a hard energy ceiling. That ceiling matches if space itself has a resolution limit. Like pixels zoom in far enough and reality breaks. Beane's preprint caused a debate still unresolved today. The experiment to test it properly is running right now. Meanwhile, quantum mechanics has been offering clues for 80 years. The double-slit experiment, the one that broke classical reality. Fire one electron at two slits. It goes through both. Watch which slit it uses. The interference pattern vanishes immediately. Richard Feynman called this the central mystery of quantum mechanics. The electron doesn't become definite until it is observed, rendered. That word, rendered, is not accidental. In a simulation, objects are only computed when observed. Quantum mechanics works exactly this way. Profound or suspicious? Is quantum indeterminacy fundamental or an optimization strategy? Dr. Hossenfelder at the Frankfurt Institute pushes back hard. She argues quantum indeterminacy is not a rendering trick. No evidence of optimization. Vacuum fluctuations exist everywhere, always. An efficient simulator would not waste resources computing the unobserved. Our universe is wasteful. Billions of galaxies with zero observers. When we read Hossenfelder's arguments, we sat with them long. The hypothesis remains unfalsified, but not confirmed either. The universe is information. Physics increasingly agrees on this. John Wheeler coined it. If from bit, reality from information. Every physical law is expressible as information processing. The question, is information primary, or is the physics? Consider what we build. Quantum computers now solve chemistry problems. They simulate quantum systems by being quantum. The line blurs. In 20 years, molecular simulations at room temperature, real time. In 50 years, we could simulate a small ecosystem. Simulations grow in scale and fidelity exponentially. Trajectory is clear. Under Bostrom's logic, someone eventually builds a universe-scale simulation. One civilization, one simulation. Then the simulated civilization builds simulators. Simulated minds quickly outnumber original minds. By orders of magnitude. Probability alone suggests you are not in base reality. Unless one of Bostrom's first two conditions is true. Maybe civilizations always self-destruct. The great filter is ahead. Robin Hanson at George Mason spent 30 years on this. He says Mars life found means we should be terrified. Filter ahead, life is common. Advanced civilizations are not. No Mars life. The filter may already be behind us. These thoughts connect simulation theory and the Fermi paradox. Where is everyone? Simulation theory offers one dark answer. Maybe the simulators need one civilization. This is the experiment. We pause here. Speculation and physics must be separated carefully. What is established? Holographic principle, fine-tuning mathematical structure. What is plausible but unconfirmed into gazer simulation signature? What is speculation? Recursive realities, simulator intent, meaning implications. This distinction matters. Science communication should work this way. The Matrix generation watched in 1999. Now they build detectors. That generation shaped by the story, now testing physics. The symmetry is not lost. Researchers openly admit it. The question is culture shaping. It changes how you see everything. The experiment's first result, how physicists now ask questions. Now the question physicists do not want to answer. If we found proof, would we want to know? Derek Parfit spent decades on personal identity questions. He argued, what matters is not substrate, but the pattern. Consciousness is patterns in neurons. Simulated neurons, same patterns. Your pain, love, grief, all real. The simulation doesn't diminish them. It asks different questions. In 2040, this discovery is suppressed by governments. Imagine the experiment succeeds, the data comes back positive. We have mathematical proof this universe is a computation. Tell everyone, suppress it. What happens next? Does anything change when you know reality is code? Philosophers have one answer. Physicists have a different one. And both are stranger than you expect. The physicist says, nothing changes. We knew this was mathematical. The philosopher says everything changes. Every ethical framework needs rewriting. Do the simulators have moral obligations toward us? Do we have obligations to beings in our simulations? If consciousness emerges from complexity, we may create minds. This is the unmapped ethical horizon. We are approaching it. Back to data. What does Auger's anisotropy search show? As of 2025, a small anisotropy signal detected. 3 sigma. 3 sigma. Interesting but not conclusive. Physics requires 5. Early results. The scientific community is still evaluating claims. The excess direction is not aligned with known sources. That absence of explanation is scientifically interesting, not proof. In the other version of 2040, the discovery is announced. Stock markets barely move. Religion incorporates the finding within months. The existential crisis lasts 3 weeks. Then people have lunch. This is how humanity has always responded to paradigm shifts. Copernicus moved us from center. Life continued. Science accelerated. Darwin removed the divine design. Life continued. Medicine accelerated. Quantum mechanics broke determinism. Life continued. Technology accelerated. Simulation confirmation would be the 4th great de-staring. We would know the simulators exist. That is not nothing. The most interesting question becomes, can we communicate with them? A physics question, connected to the holographic principle. The universe boundary may not be an edge, a membrane. Building detectors, sharpening questions. The experiment continues. A cosmic ray strikes an Auger detector now. Data flows. That data contains a simulation signature, or it does not. Either answer tells something profound about what we call reality. The person who will know may already be alive. Full investigation penned in the comments. We watch this together.